Okay, so today is day 33. We're going to be factoring trinomials. Yesterday we talked about factoring the greatest common factor. And factoring means to break apart. Okay, break apart. So we talked about the GCF. Factoring, what does factoring mean? Remember yesterday, what does factoring mean? Factoring. Okay. Remember yesterday I talked about the phi. I said, guys, stop it, stop it, stop it. What did that mean? What does factoring mean?
To break it up.
Break it up. Yeah, break it up or break apart. Okay. What does factoring mean? Break it up or break apart. Break apart. Okay. Again, one more time, everyone. What is factoring? Break apart. Good. Okay. Please end your conversations. We are doing the lesson now. Okay. Thank you. Okay, so anyways, here are the steps. If you're on the video, please write these down. And here we go. We're going to move on. So yesterday we did this as an activity in the class. Remember the worksheet, and you had you multiply, right? The original problem said 2x plus 5 times x plus 3, right? Remember this? Don't write anything down. Okay? And then we set up a box, right? Remember this? And then you worked out the box and it looked like this, right? There's something special happening in the box here I want you to see. Take a moment. I want you to discuss what do you notice inside this yellow box here. And the hint, use math operations, okay? Really take this seriously. Let's have you take about a minute to talk with your group. What do you notice? What pattern do you see? And there's a hint at the top. Use math operations, okay? What do you notice? Okay, let's see some guesses. I want to hear, what did you notice? What did you notice? Anyone? Yeah, Victor.
That the top left is always going to be x squared, and that the top right and the bottom left are always going to be regular x's.
Okay,
The last number is always going to be regular.
that's true, but what if I switch numbers around? I want you to know that is true, but I can move these around. Sometimes they could be moved around. So that's not always the case. I can move this one over here and move them. Depends on the original problem. That's a good observation, Victor. Thank you. What else did you notice? Any other guesses? Yeah, Seth.
Kind of like when you foil.
Yeah, that's kind of what it looks like when you foil. Remember yesterday we foiled, or a couple days ago, and then we did this. Okay, anything else you notice?
There's only one normal number.
There's always going to be
One normal number? What does that mean?
Like there's only one number without an x in front of it.
Okay, that's true. One constant, you mean? That's true.
always going to be multiplies.
Okay, that is what we're doing here. Eyes up at the screen. Here's a hint, okay? Ready? What's the relationship between these two? Okay, the green numbers and the purple numbers. Okay, talk to your group again. See if you can find a relationship. Okay, ready? Go. Okay, good. So, good discussion here. Let me see if I can get some new guesses. Remember, there's a hint. Use math operations. Remember, math operations: add, subtract, multiply, or divide.
Yeah.
Okay, so, anyone see anything? Yes. How do they equal that? That sounds...
So like 6x times 5x.
Okay, Michael and Robbie, you guys are on warning. So that's right. If we multiply 2x squared times 15, what's 2x squared times 15? 30x squared, right? So if I multiply these green numbers together, I get 30x squared, right? One more time. So good. So 2x squared times 15 is? Good. Thank you. And then 6x times 5x is? Good. Did you all see that? So check this out. When I multiply these out, right, and I'm adding these all together, eyes up here, right here, I'm going to make a little space right here for us. Right? You said that I'm supposed to add these together. I got 2x squared, and then I got 6x, right? right? And then I got 5x. And then I got 15 right here, right? Don't these two outside numbers need to multiply together to be 30x squared? You see that? And don't these inside numbers multiply to be 30x squared? You see that? Do y'all see that? Because that's the whole point of this. Again, don't 2x squared and 15 have to multiply to be what 6x and 5x equal to? Yes?
Yes.
Okay, good. Let's have you talk in groups. Just explaining that relationship. It's super important that you get that right now before we move on. Ready? Go. Okay, so that's super important because today, check this out. This is what we're doing today. Sorry, this is the big idea, but we're going to pretend like we're starting with this. I'm going to erase everything. Put it back now. Okay. I'm going to erase everything. We're going to start down here and we're going to work backwards to get to here.
Oh, I know how to do that.
Does that make sense? That's called factoring. You see how we're going to take this original problem and factor, break it apart to here? Okay, so, but we need to understand that the cross multiply thing, okay? So we'll talk about that today, okay? Anyways, here we go, numbers 1 and 2. Now I know teachers have taught you something different. I know I've taught my students different things a couple of years ago, so but this is a different way to do this that I want you to know because it's very mathematical and it helps you understand the numbers better. Okay, so factor. See the directions that say factor? Eyes up at the screen, please. I'm teaching you right now. So factor means what again, everyone?
Break apart.
Good, break apart. Okay, so we have n squared plus 32. I'm going to bring those down first, okay? Whenever I do this, I'm going to take the original problem, and I'm taking the first and last term, and I'm going to bring them down, okay? Just pencils down right now. Just watch, because every time your head's down, you're not watching up here, okay? Pencils down, just watch. Okay? So again, I'm bringing these down, all right? Then I'm going to multiply n squared times 32, because that's one of the cross products. So n squared times 32 is, everyone? 32n squared, okay? So I want to ask myself, I want to break 12n apart with two numbers, okay? That multiplied together to be 32n squared, okay? So maybe 1n, right? 1n plus 11n. Is 1n plus 11n 12n? Oh, okay, I'm sorry. 1n plus 11n? Okay.
If you multiply those together.
Okay, just listen right now. Is 1n plus 11n equal to 12n? Yes or no?
Yes.
Good. Is 1n times 11n equal to 32n squared? No. So then I can't use that, okay? So let's try 2n, okay? So just listen right now. 2n and 10n equals to 12n, but 2n times 10n is 20n squared. That doesn't work either, so I'm going to try that again. Next one, let's do 3n, right? 3n plus 9n. 3n plus 9n is 12n. 3n times 9n is not 32n. It's 27n squared. That doesn't work. Let's do the next one. Let's try 4n and 8n. Okay, 4n plus 8n is 12n. 4n times 8n is 32n squared. Does this work?
Yes.
Okay, good. Raise your hand if you could have done that the first time in your head. Okay, a lot of you could have. That's fine. That's why we're practicing this, okay? But that's the idea. Okay, so check this out. Next part. Eyes up here. Then we have to break it apart we factor by grouping. We're going to put parentheses around. We're going to put parentheses around the first term. And then we're going to do GCF. What's the GCF of these two, I asked myself? It's n. So I'm going to take out an n, right? Remember yesterday's lesson? So n squared divided by n is n, okay? 4n divided by n is positive 4. Okay? Did y'all see that? Yes. Then I'm going to do this again. I'm going to draw parentheses around the second two. Eyes up here. Eyes up here. And then I'm also going to put a plus sign in the middle. Super important. Ask myself, what's the GCF in the middle here? It's 8. And it's not just 8, it's positive 8. Okay, so I'm writing down positive 8 here. Then I think, what's 8n divided by 8? N. Right? Then 32 divided by 8 is positive 4. Does that make sense? Now I'm noticing there's what common binomial is in both of these? N plus 4, right? So this is like, there's two terms here. There is this whole term and then this whole term. So we have n plus 4 on both of them. So I'm going to factor out n plus 4 here. And we're going to factor out. And I ask myself, this first term divided by n plus 4 is n. Okay? Second term divided by n plus 4 is positive 8. Okay? Does that make sense? And then we're done. We just factored it. Okay? Another strategy you could do is just copy n plus 4 down here, copy the n down, and copy the 8. Okay? Raise your hand if you want to explain number 1 one more time. Okay, eyes up at the screen. One more time. Pencils down. There shouldn't be any pencils up because I want you to stare. Every time you stare at your paper, you're not staring up here, and it doesn't work. Okay? One more time. So, first thing you want to do, it says factor. Read the directions. Factor means break apart. Yes? So I want to take, I notice this is a trinomial. So I'm going to take the first and the last term. Okay? And I'm going to take n squared and positive 32, bring those down. Okay? Then I got the middle term. Okay, I need to break that apart, but I need it to multiply it. Seth, eyes up here, eyes up here. We have to multiply n squared times 32 to figure out what it's equal to. So we got n squared times 32 is 32n squared. Okay, then I'm going to figure out what combination adds up to 32n but multiplies to 32n squared. Okay, so we have positive 4n and positive 8n. Okay, so we got 4n plus 8n is equal to 12n. Yes? And then we got 4n times 12n is equal to 32n squared. Okay, so 32n squared. So now we're going to write parentheses around here. Just leave it up here. Thank you. Okay, so we're going to put parentheses around here. We got n squared and positive 4n. We want to put parentheses here. Okay, that's just something you have to do. So what can I factor out of n squared and positive 4n? I could take out an n, right? So we got n times, what is n squared? Well, it's positive n. 4n divided by n is positive 4. Okay? Second one, I'm going to put parentheses. I'll use orange just to separate a little bit. You see? Okay, and I'm also going to put a plus sign in the middle because I want to make sure that I know that I'm adding these two. It's not like I'm multiplying all of a sudden. Okay, what's the GCF out of the second one? 8, right? So I'm taking out positive 8. 8n divided by 8 is going to be n. Okay? 32 divided by 8 is positive 4. Make sense so far? Okay, good. You notice how there's n plus 4 on both of them? We're going to take that out. We're going to bring it down to the bottom. And then we're going to take the n and the 8, bring those down. And then we're done. Okay? Make sense? Good. I'm really glad you're all staring up here. Let me do it one more time with a different problem. Ready? No writing right now. Okay, so the second problem now, and of course you want to box your answer. Okay, second problem. We got 5b squared plus 33b plus 18. Eyes up here. So we want to take 5b squared. I notice it's squared, and those last term's a constant. There's a term in the middle, so it's a trinomial. I'm going to try to break it apart. Okay, ready? Eyes up at the screen. You got 5b squared I'm going to bring down. And then we got positive 18 I'm going to bring down. Okay, so I want to figure out, I want to break this apart, so I need to know what to multiply it to. 5b squared times 18 is going to be, well, 5 times 18 is 90, and then we got b squared, right? So 5b squared times 18 is 90b squared. So I need to figure out what times what is going to equal to 90b squared, but adds up to 33b. Okay, so that one's pretty easy. I'm pretty good at this, right? 30 times 3 is what? 90, right? So can't I use positive 33 and positive 30 and positive 3? Yes? So, and I want to make sure it has b's there. So 30b plus 3b is 33b, right? 30b times 3b squared, 3b is going to be 90b squared. Okay? Now I'm going to use my parentheses here. Okay? What can I factor out of 5b squared plus 30b? 5b. Okay, open parentheses. 5b squared divided by 5b is b. 30b divided by 5b is positive 6. Okay, then I'm going to put parentheses around the second term and add a plus sign in the middle. So sorry, it's all wide right there. What's the GCF of 3b and 18? 3, positive 3, right? So I'm going to bring out positive 3. Open parentheses. 3b divided by 3 is b. 18 divided by 3 is positive 6, okay? Now, do you notice that I have the same common binomial in both of these terms? You all see that? So we got b plus 6. We're just going to bring that down. We're going to factor that out. And then we have 5b. I'm using a different color here so you can see where it went. Plus 3. Y'all see that? Okay, awesome. So, that's your final answer. We're breaking apart. This is hard, right? It takes a little bit of mental work. I used to teach this thing called Xbox, but that doesn't help you because when we do complex numbers, you can't really, or complex problems, it doesn't help you. And a lot of you are going to go to pre-calc next year or advanced math. And I expect all of you could keep going. That's totally fine. You're going to all make it. So, but this is, you need to know how to break things apart, okay? All right. Questions on numbers 1 or 2. Now you could ask questions. Anyone? Anyone have any questions? Yes.
What if the other parentheses doesn't have the same number?
Okay, good question. Eyes up here. She asked, what if the other parenthesis doesn't have the same number? That means either you did something wrong or you can't factor it. Okay? So that's a really great question. Let's say that said b plus 7 like right here. Like this one, b plus 7. And this was b plus 6. You couldn't factor it. You made a mistake. Or you just can't factor it, okay? Okay, that's a really great question. Thank you. Okay? Okay, here we go, number 3. I'm going to hide number 4. We're going to do number 3 together, so let's write number 3 in your notebooks. Everyone's writing number 3 in their notebooks. Number 3 in their notebooks. Number 3 in the notebooks. Okay, here we go. So, on number 3, turn to your neighbor, tell them what you would do first, or someone in your group.
First, I'm going to see what times what equals 30.
Okay, what am I going to do, everyone? Okay, outer numbers. What's x squared times 30, everyone? Good, so I'm just going to put that on the outside just so I have that, just like a little mental note, okay? And then I'm also going to copy x squared down and positive 30 down. Now, on the inside, I want to break apart positive 13x. So what can I rewrite it at? That? So it adds to that, but also multiplies to 30x squared. Good, so we're going to write plus 10x plus 3x, right? Those are the only numbers we could really use. Well, you could also use 1 and 13, but that, or no, 1 and 12, but that wouldn't work. Okay, cool. Now we're doing this together. We're putting parentheses around the first term. What can I factor out of the first term here on this problem?
X.
Good, so we're taking out x. Okay, so we got x plus what?
3.
Nope. X plus 10, right? Okay, on the second one, I'm going to put parentheses around the second binomial. What can I take out of 3x and 30, everyone?
3.
10 or 3? I'm hearing... Okay, positive 3, good. Okay, so 3x divided by 3 is what? 3x divided by 3 is what?
X.
Okay, cool. 3x divided by 3 is x, good. 30 divided by 3 is 10. Right? What do you notice in both of these binomials? Remember what Maddie asked? What happens if they're not the same? Can we keep moving forward? No, but are they the same? Good, so that means we're doing it right. So what can I factor out still? X plus 10, that's right. So we're going to take out that x plus 10, and then what are we multiplying it with, everyone? X plus 3. Look at that, you just factored this trinomial. Give someone around in your group a high five for doing it correctly. Everyone's getting high fives. High fives, I don't see high fives. Everyone's doing a high five. High five, Deb. That was pretty good. I like that. That's kind of fun. Okay. Oh, you kids are funny. Okay, number 4. Okay, number 4. Let's see you try to do this. Well, let's start off, okay? Let's write down number 4. I'm going to start us off, and then you're going to finish it, okay? So we got x squared minus 4x minus 12. Okay? I'm going to bring down the x squared and the minus 12. Okay, what's a times c, or x squared times negative 12? Negative 12x, good. Okay, what times what is going to be equal to negative 12x squared, but adds up to be negative 4x? Turn to your group. talk about those combinations.
Is it 6 and 2?
You get a 4 and what? 8 times 4 is 32, though.
Oh, crap.
Okay, what are my two? Good. What? 6 and 2. Okay, good. So what are my two terms, everyone? Negative 6x plus 2x. Good. Okay, I want you to finish up the problem for me on your notebooks. You're going to write down the final answer on your iPads. Everyone's working quietly right now. So you should have, put parentheses is what I should have seen you do. Here we go. Put parentheses, put a plus sign. We can factor out an x. We got x minus 6 times, plus 2 times x minus 6. So then we got x minus 6 times x plus 2. And there's your answer, right? Yes? Questions on this one? Okay, continuing on number 5. Okay, number 5. Okay, I'll start us off here. We got 2n squared plus 7n plus 3. What's 2n squared times 3, everyone?
6n squared.
Good. Okay, I'll let you finish up this problem on your own. Go. Eyes up here. Okay, so what are the two numbers that multiply to be 6n squared but add up to 7n? Okay, so you should watch up here. Some people forgot to put the n. This is what happens. So we have to put 2n squared plus 3. Watch up here. Some people put 6n, eyes up at the screen, and they put like plus 1 here. It's supposed to be plus 1n, right? Right? Okay. And then we will put parentheses around here. Put the addition sign in the middle. Okay, what's the GCF of the first binomial?
2n.
2n, right? Okay. Then we got n plus 3. Yes? Okay, the next one. 1 plus 1, right? What goes into both of them? What's the GCF? Okay, 1, right? What's 1 times 1n? And good. What's 1 times 3? 3, right? So I think it's confusing to you because you were like, oh, it's just a 1. Yeah, you could still do that, right? Do you see that? Yeah, it's a little confusing. That's why it's there. We want to do this now, not on the test, right? Okay? So, what's the common GCF of both of these terms now? N plus 3. Good. So some people are still confused with this. You see right here, this is a term, and this is a term, right? What's in both of these terms again, everyone?
N plus 3.
N plus 3. So the GCF is n plus 3 here. And then we have, if we were to take this first term divided by n plus 3, all we're left with is 2n, right? And if we take the second term, we divide by n plus 3, all we're left with is plus 1. Do you see that?
Yes.
Okay, good. I'm just answering some questions because some people were still confused. Does that make sense? Okay, let's have you turn to your neighbors. I want to hear a little discussion on where you got stuck or if you made a mistake. 20 seconds. Ready, set, go. Oh, not quite yet. Back here. Okay, last problem. Last problem. Shh. Okay, I'm going to start you off because I worked with the other period and they got stuck on this, okay? So, 5n squared minus 13n plus 6, okay? What's 5n squared times 6, everyone? Positive or negative?
Positive.
Good, okay, positive 30, okay? 30n squared. Okay, don't start yet. Listen, eyes up here. We need something that's going to multiply to be get together to be a positive, right? What's a positive times a positive, everyone? Positive times a negative?
Negative.
Negative times a negative?
Positive.
Good. So what do you predict your two middle numbers to be?
Negative.
Okay, good. That's it. That's it. You work by yourself now or with your group, okay? Figuring this out. Go. Okay, so 5n squared minus 13n plus 6, we should write 5n squared on the outside. Positive 6 on the outside also. What's the combination of the inside that we should have, everyone? Negative 10n and negative 3n, right? Okay, good. Then we do our parentheses. We got 5n squared, and we're going to put parentheses here. You see how we wanted to keep that negative? Put parentheses there. Eyes up here. Some people made mistakes. Okay, I could take out a 5n from the first term, leaving n minus 2. Second term, I could take out a negative 3, right? And then we got n minus 2 again. And then I'm checking my two factors. You see right here? These are both the same, right? So we could take out, what can I factor out, everyone? N minus 2. And I could take out, and then from that, I know it's going to be 5n minus 3.
Oh,
Makes sense? Yes. Because I could factor out, these are two terms right here. Shh. I'm trying to answer a question. Please end your conversations. Okay? 5n times n minus 2 here. And then I got negative 3 times n minus 2. What's the same thing that's in both of these? N minus 2. Good. So we got n minus 2 times what is 5n times n minus 2? Just 5n, you see? And then n minus, because there's a minus 3, bud, right here. Putting it right here. You see I could take out a negative 3 here and here? That's why. Okay? Yep.
What if you switch 10n and 3n around? Would you still get the same answer?
Yeah, that's a good question. You want to try that? Okay, here we go. I still have to give you back your test, so... What do you want? You want me to give your test back, or do you want your... Okay, cool. So this ends the lesson. I'm going to record this in a moment, okay? Okay, this is what would happen if we had a... let's say we set up this problem differently. This was asked 5n squared minus 3n minus 10n. So we have 5n squared minus 3n minus 10n plus 6. So we can actually group these up. The first group we have n coming out. So we got 5n minus 3. The second group we could take out a negative 2, which is going to be 5n, right? Minus 3 again. So we get the same answer. We got 5n minus 3 times n minus 2. Okay? Anyways, I wanted to show you both ways. It's the same answer. That concludes the lesson.